Tēnā koutou katoa, and welcome to our fireside chat and conversation with Professor James Renwick. As many of you will know, James is New Zealand's leading climate scientist, so we'll try and control that kind of comment. I nearly put arguably in there, but I thought leading would probably fit the bill because, quite frankly, that is the case. James started his career as a weather forecaster with the Met Service and is now Professor of Climate Science at Victoria University of Wellington, Te Herenga Waka. He has been heavily involved in the work of the Intergovernmental Panel on Climate Change, which many of us will have heard of and seen the report of, and is one of our climate change commissioners. He was the winner of the Prime Minister's Science Communication Prize in 2018. James, welcome. Thank you for clearing some space in the diary, and especially given all those critical activities that you're undertaking at the moment for us.
Well, kia ora, Mike, and kia ora koutou. Thank you very much for the invitation to have this conversation. I can't think of a more important conversation to be having, so it's a real pleasure to be with you today.
Thanks, James. Yeah, now I'm going to start off with a quick quote, if I may, and I'm going to quote your biography, your mini biography on the Victoria University website, which says, "I am fascinated by the general circulation of the atmosphere, how the atmosphere transports energy and momentum, and what it does to achieve this." Can you tell us a little bit about that journey and that development of that fascination and how you became interested in climate science and climate change?
Certainly. I grew up in the middle of the South Island, a little village called Springfield. Still there, but it's down to about 100 residents, I think, now. And if you grow up in a place like that, on the inland part of the Canterbury Plains, you see a lot of extreme weather. Everything from really hot northwesterly winds to thunderstorms, snow, hail, frosts, as well as baking heat in the summer. And I think that really got me interested in thinking about the weather. And as it happens, I've always been very good at maths and physics, which is what you need if you're going to get into weather prediction. And it was kind of a happy accident that I ended up going to the Meteorological Service to train as a forecaster. But it really was a passion I've had all my life. And as time's gone on, I've gone from thinking about day-to-day weather changes to season, year to year. And now we're looking decades and centuries into the future and into the past, actually. So it's been a natural progression from just looking out the window when I was a kid at home to looking at global pictures on computers of what's happening with the global climate these days.
Okay, that's very interesting, actually. Springfield, we won't mention The Simpsons at that point, shall we? I trust it's a different Springfield. Now getting into some of the nitty-gritty, we have a lot of media coverage, of course, at the moment about climate change. And one of the things that probably we should get addressed pretty early is the question that I think was addressed probably some time ago, but it's worth going back to sometimes, which is how can we be sure that the increases we're seeing now aren't part of a natural cycle?
That's a great question. And there's lots of so-called natural cycles. Some, like an El Nino event followed by a La Nina event, let's say, are just ways the climate system varies all by itself. And that does change global temperatures. The thing is, though, the global temperatures go up, let's say, in an El Nino because the amount of energy in the oceans goes down a little bit. There's an exchange of energy between the ocean and the atmosphere, but the total amount of energy in the climate system doesn't change. And most of those kinds of natural variations, so-called, they just move heat around the climate system without changing the total amount. So we can rule those out because we know very well that the total amount of heat in the climate is increasing. The other sorts of natural cycles you hear about are things like the ice ages, cycles over much longer timescales, thousands of years, even tens of thousands of years. And they are controlled by the amount of sunlight coming into the Earth and the amount of greenhouse gas in the atmosphere. These are the two things that really control all of this kind of activity. So if it was a natural cycle that was happening at the moment, we'd have to be seeing either the sun becoming brighter because the planet is warming up, or the amount of greenhouse gas in the atmosphere going up. We certainly don't see the sun becoming brighter. In fact, it's got a little dimmer lately. And we do see the amount of greenhouse gas in the air going up. And the thing about that is we know actually that's because of what humans are doing. We're burning fossil fuels, we're burning fossil carbon that's been underground for millions of years and pumping that into the atmosphere. We can tell from the chemistry of the carbon that's appearing in the atmosphere that it's coming from exactly that source. So there are no other natural cycles around that we can point to explain what's happening. Left to its own devices, the Earth would be going into the next ice age about now, and we're certainly not doing that at the moment. So there really aren't other candidates. I often hear, well, it's all a natural cycle, the climate's changed many times in the past. It's true, the climate has changed many times and keeps changing, but we know for sure that human activity, humanity, is the driver right now. It's not some other natural cycle at all.
Okay, and one of the other things that we do come across a lot, and again, massive media coverage, is the number 1.5 degrees. Now, I think, again, many of us have an understanding that we need to control temperature increase. But what is so special or magic about that 1.5 degree number? Why is that half degree differential between the 1.5 and the 2, for example, quite so important?
The reality is there's no magic numbers and there's no special temperature that the Earth is perfect at for humans or anything like that. The 1.5 degrees and the 2 degrees, the bottom and the top of the Paris Agreement range, but political choices, not really scientific choices. There's no threshold beyond which we all die or everything goes out of control or anything like that. And there's no safe, perfect climate. The climate has already warmed more than 1 degree compared to the pre-industrial levels a couple of hundred years ago. And the reality is that the more it warms, the more extreme events change, the more damage there is. And the further we get away from the climate that humanity's been used to for thousands of years, we've built our civilization on the basis that sea levels don't rise and we know where to grow big areas of crops and so on. It's all changing, and the more it changes, the harder things get for us. So 1.5 degrees was chosen, I guess, as something that was attainable and was, in some senses, safe. You know, the more it warms, the worse things get. So the sooner we can stop the warming, the better for everybody. And we know from studying Antarctica and the past of Antarctica through ice sheets and ice cores, and so on, as well as looking at models of the ice on the big ice sheets in Greenland and Antarctica. If we get to about 2 degrees of warming, there's a really good likelihood that we'll lock in irreversible melting of big parts of the ice sheet in Antarctica, and we would raise sea levels by several metres. It would take a long time. It would take hundreds of years to happen. But we'd get to a point where we'd reach a tipping point, basically, where it'd be irreversible. And especially populations living in low-lying island countries, especially the tropical Pacific, they were the ones who really pushed hard for this 1.5 degree limit, because that gives much more likelihood that that kind of thing won't happen, that sea levels won't rise more than maybe another 0.5 metre or so, which would be hard enough to deal with, but it would be manageable. If we let the warming get to 2 degrees or more, we start to lock in big changes like lots more sea level rise, much bigger extremes. We've already seen, huge fires and heat waves, floods, and so on around the world. Those things get worse as the warming increases, and at some point they become unmanageable. So the 1.5 to 2 degree range was a kind of a political compromise. The bottom end of the range I would say is safer than the top end of the range, just in terms of the number of people who are put at risk of coastal inundation, sea level rise, crop failures through extreme events, water shortages, and so on. So it's there's no real scientific basis for 1.5 degrees, but we do know that the sooner we stop the warming, the better it is for us.
Yeah. And it's sad almost that you say that, because I did note even this week we've seen. I did notice a news report suggesting that the famine in Madagascar has been officially declared as attributable to climate change for the first time that's happened, because all of the others have other political issues that contribute to the and exacerbate the problems, of course. But apparently there are no other issues for the Madagascan climate. So it's with us, I believe, isn't it?
Oh, absolutely. And that's an example of the kind of thing you see in other parts of the world. Usually, you can't say climate change caused this event to happen. That's not a sensible statement, really, but it's about climate change making things more likely. And if you've already got political problems or some kind of instability in a country, such as Syria, for instance, a big drought, such as the one that occurred a few years ago that we know was enhanced, made worse because of climate change, that can be enough to push the community over the edge and, a small war starts. So this is what the Pentagon calls climate change a threat multiplier. Just makes bad situations worse in all sorts of.
Which, now you mentioned the Pentagon, that triggers something else. Not going back to American history for more than, shall we say, between 12 and 60 months or so. What sort of things do we need to be aware of about misinformation on climate change? What are the dangers around that?
Yeah, well, I think misinformation is dangerous always. We need to understand what's going on and take the right sort of action. And I think around climate change, the idea that it's not something to worry about, which I still hear about, either it's not happening or it's a natural cycle and there's nothing we can do, and we just shouldn't concern ourselves with it. It'll be manageable, and other problems are much more pressing. I find that very worrying because it's the opposite of the truth. But at the other end of the scale, it's also, I'm really bothered by those who say that it's too late and it's catastrophic and people are going to die. I've read that humanity will be extinct by the end of this decade, which is also, in a different way, turns people off doing anything. Well, if we're going to be dead in 9 years, why would I bother buying an electric car or whatever?
Yes.
So ideas that are out there that discourage action, I guess, are worrying, whether they're at the weak end of the scale because there's nothing to worry about, or at the very strong end of the scale, it's all too late when it's going out of control. But those are the things I worry about most, because the reality is we know exactly what's going on. We know that human activity, us, we're driving this. We know that when we stop doing that, it'll stop. The warming will stop almost immediately when we stop emitting greenhouse gases, especially carbon dioxide. So we have all the power. It's never going to go out of control. We can choose when we want to stop. We just need to do it. And it is definitely something to worry about, because if we let the changes get too large, it just won't be manageable at some point. It's kind of been manageable in a lot of countries so far, but as time goes on, there'll be more and more places around the world where it's just too much, too expensive, too difficult. People are going to have to move, and that's when things start to get very tricky. And organisations like the Pentagon start thinking about what that means for national security. We really don't want to go there, I don't think.
But what about the argument then that we can adapt? We're a very innovative species, and we can adapt. We have adapted to many natural changes that we've seen, some of which we might have caused ourselves, of course. But we can adapt. Why can't we just live with it and adapt? Why do we actually need to do something about it to prevent more warming?
That's a really crucial question, and at the heart of why we need to take action on climate change. And it's this idea that, yes, we have adapted where we've had to so far. And yeah, humans are very smart, clever, adaptable species. So we have a lot of scope for dealing with these problems, but there do come points where it's just not possible to adapt. You know, if your country's going under the waves because sea levels have risen 5 metres, there's no way you can adapt to that. You've got to move. And you could say that shifting to another country is adapting, I suppose, but it's a pretty drastic sort of action. And if we have really extreme heat waves and fires that, you know, wipe out big population centres in, let's say, Australia or the west of North America, or Russia, you know, all the places that are experiencing much more extreme fires these days. At some point, it's not possible to adapt. You've just got to get out of the way of where the fire is burning. So it's about how much of our current infrastructure and lifestyles do we want to retain, and what are we prepared to adapt to, I suppose. It gets more and more expensive and damaging the more we have to adapt to these bigger changes. So at some point, I think we've got to stop. Otherwise, you know, billions of people will be displaced, and I can't imagine what that would be like. The other aspect of this is that, unfortunately, carbon dioxide, which is the key greenhouse gas that's involved and the key gas that's released when we burn fossil fuels, it sits around in the atmosphere for a very long time, for hundreds to thousands of years. So it just collects. We've got to, if we're going to stop the warming getting any larger, we've got to get to zero emissions, not just turn down the tap a bit. All of the carbon dioxide we emit stays in the atmosphere for so long, it just builds up. So if we want to stop that build-up, we have to get to zero emissions. And the sooner we do that, the sooner we stop the warming. So even though it's a problem that will go on for hundreds of years into the future, it's what we do in the next 10 years, roughly, that will define a lot about how much higher that spike in the carbon dioxide will get and how much higher the spike in temperatures and the changes in the climate that go along with that will get. So yeah, it's a question of how much we can adapt and how much we're prepared to spend on it, I guess.
Yeah.
That's one of the other main questions.
And a lot of those scenarios, for want of a better phrase, that we see talked about have come from the work of the IPCC. How did you become engaged with that IPCC work? What was behind it all?
Well, that's a good question. I suppose in the mid to late 1990s, I really started to understand just what a big problem climate change is. The first IPCC report was published in 1990, the second one in 1995, the third one in 2001, and so on. And it was during the writing of that third one, I really started to think that this is a problem. I actually contributed some words. I was a contributing author to the third assessment report because I knew someone who was involved. So when the call came around for the next IPCC report, the fourth assessment report, was published in 2007. So this was the early 2000s. The Ministry for the Environment just put a general call out to the science community for people who might like to come along and find out about the process, might like to have their name put forward to the big plenary session, big bun fight that happens in Geneva to decide who's going to be the authors on these things. So I said, yes, put my name down. And I had no idea how that would work or whether I would be selected, but I was. And I suppose that was because by that stage, I had enough of a track record in the science that, you know, I guess people felt I could be trusted to do a good job. And so I was selected for that fourth assessment report in the early 2000s. And for better or worse, I put my name forward for the subsequent report since then, and I've been selected again. And I guess once you've got a bit of a track record, it maybe becomes easier, although they do like to see turnover and younger people coming through, which is great. So it was partly a sort of dawning realisation of just how important this problem is, and I would say getting lucky for being selected back about 20 years ago.
Well, you've described that process going back 20 years or so. What's to come? Where are we in that IPCC process, and what are the next stages? What are the potential outputs that we can look forward to that, and how they relate to New Zealand?
Right. So what I've worked on throughout my involvement with the IPCC is the Working Group 1 report. So this is the first of 3 reports that comes out with each of the IPCC assessments. Working Group 1 is the physical science, so this is what I study, looking at how temperatures, rainfalls, winds, etc. are changing and why, and what the future looks like on that front. Working Group 2 is all about, it's probably the one that's most relevant to people. It's about impacts, adaptation, vulnerability, or what are these events going to do to populations and to ecosystems. So the Working Group 2 report is, I guess, the most relevant to people's activities, and that's still in the works. That report will come out in about 4 months or so, at the end of February or March, early next year. And then the Working Group 3 report on mitigation, which is how we fix this problem, how we move to renewable energies, all of the new technologies around either stopping putting these greenhouse gases in the air or finding ways to take them out once they're up there. That'll come out a little bit later again, but it's March or April of next year. So these 3 reports are part of each of the assessments. So in the short term, those are to come. And the Working Group 2 report has a whole chapter on the Australia-New Zealand scene, and that'll have a lot of information about what is happening here and what is expected to happen here over the next 100 years or so in terms of sea level rise and coastal erosion, changes in the surface climate, rainfall and temperature, mostly what that means for agriculture, etc. So I think that'll be really useful for policymakers and planners when it comes out in a few months. So that's the one I'd say that's probably, in a sense, most useful for organisations like local government or central government for that matter.
Okay. Well, I've had a little play with the web on the IPCC website, and it's actually quite fascinating. You can input various different combinations of temperature increase and the like, and see quite what colour the country changes to. What do you think would be the key tools that are available to practitioners of carbon management that we might be able to find and source through the IPCC website or other materials?
Yeah. Well, one thing, and I kind of alluded to, one of the products that was generated as part of this assessment report is the so-called interactive atlas. And this is a website you can go to, and like you say, you can dial up different scenarios for the future, different warming levels. You can look at all sorts of variables for any part of the world. So you can look at what's happening over New Zealand, for instance, in terms of temperature extremes and so on. So that's really useful for at least broad brush pictures of changes for the future in the actual climate itself. The catch, I guess, with that is that it's all based on global climate models, which are great tools, but they are relatively coarse scale geographically. They have grid points to represent the world. And a typical climate model, each grid point is maybe 100 kilometres apart, nearest one. And, so Aotearoa can fall in the gaps between the points of some of these models. So the details of what happens here are not captured well. The big mountains mean we have very different climates in different parts of the country. So you really have to look at so-called regional climate models, much higher resolution models that run in particular areas. And this is the kind of work that, for instance, NIWA does very well, and they're working right now on what's called downscaling the global models to get a better picture, sort of zooming in on what's happening in different parts of New Zealand. So that as that work comes out through the Ministry of the Environment, that'll be very useful, I'm sure.
Do you have any idea when that might be published, some of that output?
As soon as possible, I imagine. I'm not exactly sure. One thing happening at the moment, or starting to happen, is the Ministry for the Environment has commissioned a short report, a sort of a short update based on what we have at the moment, the information we have at the moment. What can we say about the guidance that exists for New Zealand at the moment? Is there anything sort of clear and it needs to change? So it's again sort of a fairly quick, broad brush look at the information we've got right now, which that'll be written up and available, I think, within about 6 months or so. But the climate modelling, the regional modelling done at NIWA and so on, that's time to do. I'm not exactly sure of the time frame, but I'm thinking it'll be at least a year away, if not longer, before we really hear about that.
I'm sure, of course, yeah, and I'm sure, of course, a lot of that will feed into the work of the Climate Change Commission as well. Now, you are one of our commissioners. What is your role with the Commission, and how do you see the Commission moving now that it's published its first advisory around budgets, and we're all looking forward to the government's response for that, even though it's been delayed a few months. What is your role with the CCC, and what's your input to their budgeting process?
Right. Yeah, and it might all seem a bit mysterious. I don't know if many people really understand how the Climate Change Commission works, but it's a statutory agency. It's a bit like the Parliamentary Commissioner for the Environment's Office. It's not a government department set up by government, but it's an independent agency to advise government. So it has 3 dozen at the moment, roughly, employees, people who actually do the work. And then there are the commissioners. I'm one of the commissioners. And the commissioners are like a board of directors, in a sense. We oversee the work of the commission and sign off on the advice and the other documents that come out of the work of the commission staff. And we do have, because the Climate Change Commissioners all have specialist knowledge, in my case, about the science or about adaptation, climate change, or greenhouse gases, or etc. We do tend to get involved in the actual work a bit. So I had a small hand in some of the writing around the actual changes in the climate and the role of different gases and all this kind of thing. But mostly, it's an oversight role, so we need to be confident ourselves that what's being generated is scientifically correct and acceptable. Not major flaws in the logical, the thinking, or the modelling, for that matter. So it's quite a high level role, really. It's governance, I guess you would say, and the people who actually are employed by the Commission are the ones who do the work, and there's a fabulous range of people. The Climate Change Commission has, I think, hoovered up a lot of the expertise in the country around both the problem, the scientific problem, but also the effects on the economy and different parts of the economy, on agriculture, on transport, on business, and so on. And so we have people at the Commission who come from Treasury, from the Ministry of the Environment, from Parliamentary Commissioners to the Environment's Office, and so on. A lot of people who have really good policy and scientific expertise. And they're the ones who've been working their butts off for a long time now, getting to where we are at the moment.
Mm-hmm. Now, you mentioned, just picking up on point you mentioned a little while ago, which is the fact that CO2 lasts for a hell of a long time in the atmosphere. And we've got another problem, the hidden, well, it's probably not hidden, but the one that kind of gets swept under the carpet a little bit, might I suggest, in New Zealand, which is that of methane. How would you describe the relative importance of tackling the different types of GHG emissions?
Yeah, another fraught question, and certainly in a country like Aotearoa, you know, we're a developed country, and yet we have this big slug of biogenic methane that the country emits. That is methane that's emitted through agriculture, mostly sheep and cows burping methane as a byproduct of the grass and so on that they eat. And the issue is, it does come down to the lifetime. How long are these gases in the atmosphere? Plus, how much of this stuff is there? There's a lot more carbon dioxide in the air than there is methane. But straight away tells you that it's a bigger problem. But methane is a much more potent greenhouse gas, meaning it absorbs more heat than a given molecule of methane absorbs more energy than a molecule of carbon dioxide. So it warms the planet more. The thing is, though, it only stays in the air for 15 years or so, a little bit less than that on average. So its effect is quite dramatic while it's there, but it goes away relatively quickly. So we need to treat the so-called long-lived gases, that's mostly carbon dioxide, but also nitrous oxide, which again is involved with agriculture, with fertilisers and waste and so on. We need to treat those a bit differently to the so-called short-lived gases, the ones that are in the air for maybe only a decade or that sort of order. And this has been recognised in legislation here. We're one of the few countries, if not the only country in the world, that has a so-called split gas target domestically. So the Zero Carbon Act talks about zero net carbon dioxide emissions by 2050, which is what you need to do to stop the overall warming, and a reduction in methane, but only 24 to 47% reduction by 2050. So getting up to maybe a halving over the next 30 years. And the reason for that is because the methane and other short-lived gases stay in the air for a relatively short time. As soon as you start to reduce the emissions, the amount in the atmosphere is going to start to go down. It's just the way the chemistry works. So it's not so urgent to get the methane to zero. Whereas carbon dioxide, you have to get to zero. You're going to stop adding to the problem. So in that sense, methane reductions are less urgent than carbon dioxide reductions. And it's a bit of a worry that if we get right into methane reductions, we'll take our eye off the ball with carbon dioxide, which would be a bad thing in the long term. But methane is a potent greenhouse gas, so reducing methane emissions is always going to be a good thing in terms of reducing warming. And there's been various estimates done. The pledges that were signed up to in the Glasgow meeting recently about reducing methane by 30% by the end of the decade, I think it is. That would, if it works, that would be a cooling effect, and it would offset some of the warming from carbon dioxide. Provided that we're getting on top of the carbon dioxide emissions, then reducing methane is a good thing to do. So if we can see the carbon dioxide emissions starting to go down and we get on top of the methane, great stuff. If we only do the methane and not the CO2, then in the long run, we haven't really reduced the problem much more. So I don't know, it's quite a complicated issue, but basically carbon dioxide is the most important thing, and methane is a significant greenhouse gas, but it is less urgent to get it under control. And actually, just to reiterate on that pledge that was made in Glasgow about the 30% reduction, most of the reductions are going to come from what's called fossil methane. So when you dig up or drill for oil and so on, well, gas is one of the main fossil fuels that comes out of the ground. That's methane, essentially. So you get methane from fossil fuel extraction, and methane comes along for the ride with oil and coal as well. It's just one of the sort of byproducts, in a sense, of some of the extractive industries. And there's quite a lot of leakage through the fossil fuel extraction process. So with the boom in fracking, and just generally drilling for oil and so on. There's been a lot of methane put into the atmosphere. Most of the reductions through these pledges that have just been made will be getting on top of those emissions. So fixing the leaky pipes, essentially, and capping off methane emissions before they get into the atmosphere if you're extracting fossil fuels of any variety. So the biogenic methane that we mostly produce through agriculture is going to play a relatively small role. So while New Zealand signed up to this pledge, it's not really expected to do an awful lot beyond what we've already promised to do.
Well, that's one of the things about COP26, and one of the things I wanted to ask you about COP26 and the outcomes. Was enough done? Was enough agreed? Where does it leave us? And are we still in trouble? I mean, I appreciate that we're probably still in trouble because most people are saying we're not going to hit the 1.5. But really, what were the good and the not so good things to come out of COP26?
Well, I didn't have particularly high hopes for COP26, knowing what happened in the previous 25 of these meetings. And it's a United Nations process, so the countries of the world have to get together and agree on things. And that's, from a political point of view, it's just a really hard thing to deal with. So progress is always slow with these meetings. Slower than I would like, certainly, in terms of how the climate's changing, but it's just the reality of the way this process works. So I wasn't too disheartened by the achievements. You know, there was quite a lot of agreement around the direction we need to go, and a number of countries have really upped their ambition. Like the Indians, for instance, now have a zero CO2 emissions target by 2070. Okay, that's getting on the late side, but it's better than having no target at all, which is what they had before. So from a political point of view, there were some really positive things about countries upping their ambition or coming to the table for the first time, and a whole lot of sort of detailed things about how you measure what people are doing, the transparency of the system, international carbon markets, and all of the questions about money, the so-called loss and damage stories that essentially developing countries, the poorer parts of the world are the ones who are suffering earliest, the usual story, that those who have the least resources to defend themselves are the ones who are getting it in the neck first. And there are parts of the Paris Agreement that talk about this, about the developed world funding the developing world to adapt, to cope with the issues they're already facing. And there were advantages in how that's being handled, and again, getting countries to actually commit to putting money into the system. So that was good for a lot of the developing parts of the world. But overall, as everyone's aware, I think, you know, the groups that monitor these pledges and where we're going with emissions have already given COP26 a failure mark, that we're still going to be, well, it depends who you talk to, actually, and depends on how you run your models and what assumptions you make for the next 50 years. But it looks as though if the countries of the world actually live up to the pledges they made in Glasgow, we're still going to be more than 2 degrees of warming by the end of the century. So yeah, that's disappointing, because the reality is, if we don't take action faster, we will exceed 2 degrees of global warming. And it's hard to imagine now what that would be like, but it would not be good. It would be extremely dangerous and expensive, and you know, a lot of people will lose their lives as we get to those kinds of levels of global warming. So it's really worrying that the political leaders of the world still don't seem to have grasped the risks that we face. And they're still going through these processes of getting agreement, which are really important, but individual countries can still be taking action faster. So yeah, overall, it panned out the way I expected, I suppose. There were some advances in some areas, but the really big issues, getting on top of emissions, is still being handled relatively slowly. So, yeah.
Good and bad. 50% pass on. Great deed,
Yeah.
something like that, perhaps.
Disappointing, but not terrible.
Now, you mentioned there the importance of getting on and doing things quickly. As you know, our members are a day-to-day, dare I use the phrase, at the coalface in terms of trying to reduce emissions and trying to help out in the way that you're speaking, the micro level, obviously. If you had one key message for our members and the professionals working in energy efficiency and carbon reduction, and one key action that you think we should be doing over the next 12 months or so, what would those two things be?
Gee. Well, I think keep going, for sure. You know, the work that groups who are really looking at how we reduce emissions in the business sector and any part of the environment, sorry, any part of the economy, you know, it's great work and needs to carry on and be done as rigorously and as quickly as possible. So just keep working and make sure that you're talking and collaborating. You know, I think climate change is a global problem. We all need to work together. We need as many ideas and brains as possible working on this. And I think collaborating with as many other groups as possible is really important. So making sure that what you're doing is well known in the community and that you're talking to others who are doing similar things so that you get more power out of the overall effort on this front. In terms of what action people can take, again, I think it's about communication. The first thing that occurs to me is make sure that your elected officials, the government, understands how important this is and how much we need quick action. You know, the school strike movement has shifted the dial on the conversation quite a bit in the last few years, and there is a lot of power in political protest. Now, I'm not suggesting that every cycle modeler goes down.
Are you giving us a green flag to go and walk up to the Parliament steps there, James? And
it's all a bit fraught these days, isn't it? But everyone can send an email to their MP or, you know, get on the phone. Mm-hmm. I think political action moves if there's public support. So the more support from especially people who are in the field, in the know about what's happening, that carries a lot of weight. So making sure that your both central government officials and local government, for that matter, know about the problem and understand what needs to be done. I think that's really important.
Yeah.
So get out there. Right?
Get out there.
Yeah.
Well, it's a nice day in Wellington, as we touched on earlier on. So
yes, it is a pretty nice day in Wellington.
A good day for a demo is what you're suggesting, perhaps.
Oh, always.
Well, James, thank you very much indeed for your time this morning. It's been a fascinating journey through a little bit of your history and a little bit of what you've been doing as well, and making that contribution. So I'll relay back. Thank you for your work, and can I encourage you to see you in Parliament steps in perhaps sometime next week as we demo together? How about that?
That sounds fantastic. I'll get my placard on the go now.
So
great to talk, Mike. Thank you very much for this opportunity.
Thanks, James, and thank you to everyone watching and everyone who may be listening, if you're listening to an audio version only. And James, finally, thanks once again, and hopefully we'll see you soon. Kia ora.
Kia ora. Thank you, Mike.